talk a little bit about this chapter 13. It's talking about some more complicated ways you can load and preprocess data in TensorFlow. And I don't think it's too important to worry about the details, but there are a couple of pictures here that help. So here, you have data coming in, and you could just have slices. Then you can repeat the data if you want to. So it takes your data set and just runs it like a tape several times, so you have 3 copies of it. Then you can batch it in batches, and you'll have pieces here. So this is something you might have to do as you want to break your data into chunks and go through processes. Map is what can do something like do a mathematical operation like double the values. You can filter the data to have a condition you like here it's going to only keep the data where the sum of all the values adds up to greater than 50. You can take certain items from a data set and shuffle the items, and these are all various operations to process your data. You can read multiple files and interleave the results, which is what would happen if you have a big data set stored in many files. And you can normalize it using mean and standard deviation, so your data goes through a reasonable range, which I've mentioned many times is really important, so you don't overcount the importance of a certain feature. And so you put it all together, and your model will look like this. You have a group of data files. It interleaves them all, combining all the data. Then you cycle through it to make multiple copies of that. Then you map to adjust to mathematical adjustments. You shuffle the data. You pick out batches. And the prefetch method will keep your CPU and your GPU both working. So without prefetch, you use the CPU to load the data, then you use the GPU to train the model, then you load the next batch and train it. But with prefetching, once you got a batch of data loaded, you shove it to the GPU and it starts learning, and while that's happening, it fetches the next layer from the CPU. So now your CPU and your GPU are both running all the time. And if you have a multi-threaded CPU, you could be having both threads here working and the GPU, and this can make it a lot faster. And I think there were a couple more figures worth looking at here. That's just the TF record format. It's a binary format used to store this data. Not terribly exciting. And so here, if you have raw data, you can go to preprocessing layers, and then you'll later on add production data. So you often include whatever preprocessing has to be done, you include it in the model, so that when you add production data later to be evaluated by the model, you don't have to remember to manually preprocess it. So if you preprocess the data just once before training the preprocessing layers, then you'd have to deploy those layers in the final model. But now your production data will have to be artificially preprocessed like this, so it's better to incorporate it all in the model. And I think the rest of this is not too important to us. This one, however, is important, and we mentioned it before. This is at the heart of the large language models. The large language models create a high-dimensional space, and they now have a vector representing a word. And it puts things with similar meaning near each other. And so it will put a man will be here, and a king is here, and the same vector will connect the word woman to the word queen. That's what makes it work. This is really what's doing most of the work in the large language models. It's not actually anything special about the learning procedures. It's the encoding procedures, and this was developed gradually by researchers over the last couple of decades, a way to encode words so that similar meaning words are near each other. Now you can do mathematics on words and get meaningful answers. All right, and I think there's nothing else here that's too important. These are little details. Yeah. And we've already talked about Hugging Face in another context. Hugging Face has a lot of these data sets available to play with. So that's all I wanted to show you in that one.